Jai Shri Gurudev. Good morning to everyone students. Welcome to chemistry class. In this class we are going to study nature of CX bond. Before going to nature of CX bond, we have studied in your previous classes classification of haloalkanes and haloarenes and nomenclature of haloalkanes and haloarenes. Now the nature of CX bond we are going to study. So here observe, carbon is an element and you know X is the general representation of halogens and you know all the types of halogens, that is fluoride, chloride, bromide and iodide. These are the halides generally represented via X. So among these two, the carbon is electropositive and halogen is electronegative. Therefore, the bond between carbon and halogen is polar. Since the bonded electrons moves towards the halide side. Hence, the carbon carries partial positive charge and halogen carries partial negative charge. Such kinds of bonds we called as polar bonds. Similarly, we take an example, universal solvent, that is water. Here, after ionizing this water, you get H plus OH minus, right? Why you get like such kind of ions from water? Because oxygen is more electronegative, hence it carries partial negative charge, that is delta minus, and hydrogen is electropositive, hence it carries partially positive charge, that is delta plus. Similarly, in alkyl halides, that is in CX, halogen is more electronegative than carbon, hence these bonded electrons moves towards halogen and you get carbon delta plus and halogen delta minus, that is partial positive charge and partial negative charge. Hence this CH bond we called as what? Polar bond. This is the polar nature of CX bond. And observe among these two atoms, that is halogen and carbon, the size of the carbon is remains same, but the size of the halogens is increases from top to bottom, that is down the group. So here let's take the carbon. This is the size of carbon. We have to fix the size of carbon and take the next carbon atom is fluoride. After chlorine, the first halogen is chlorine. The size of fluorine remains same as the size of the chloride, because only one atomic number is increases for chloride. Even increasing, the electrons is enter into the same shell. Hence the size remains same or bit decreases. And the next halogen atom, the size of the carbon remains same, and the next halogen after chlorine. So its size is bit higher than fluorine. So similarly, the size of the carbon is remains same. Then after fluorine, next to chlorine, then bromide. Its size is bit higher, bromide. Then similarly for iodide, this is the iodide size. It is much higher than bromide. So write bit higher. This is the size of iodine. This is the bromide, this is the iodine, and here the size of the carbon remains same. So observe, from down the group, the size of an atom increases. Hence, this bond length also increases. Okay, remember the atomic number of an atom increases, the size of the bond length of the bond will be increases. Therefore, the order of bond length, increasing order of bond length is given by carbon iodine. That is Ci bond length is higher than CBr, which is higher than C chloride, which is higher than C fluoride. This is the increasing order of bond length. Bond length BL. This is the increasing order of bond length. That is carbon iodine is higher than carbon bromide, carbon chloride. Then the least one is carbon fluoride. Similarly, the bond strength is exactly opposite of bond length. Therefore, the bond strength of chloride fluoride is higher than carbon chloride is higher than carbon chloride and carbon bromide, and the least one is carbon iodide. So just observe, the chalk piece length is this much now. You can easily broken when the length is higher. Similarly, if chalk piece is very small piece, let's take a tablet. Its size is very less, right? So you can't break easily. It means we have to apply some energy. Then only it will broke. Like that, the bond length is less in carbon fluoride. Therefore, bond strength is higher. Hence, the bond strength harder. That is increasing order of bond strength. This is bond length and the bond strength. His bond strength is, that is carbon fluoride. Bond strength is higher than carbon bromide. Chloride. Carbon chloride, then carbon bromide, and the least one is carbon iodide. This is the increasing order of bond strength. Remember, definitely they will ask for 1 marks to write the order, and similarly the dipole moment of these atoms. Dipole moment, that is increasing order of dipole moment. Order of dipole moment is dipole moment. The carbon chloride is higher than carbon fluoride, then carbon bromide, and the least one is carbon iodide. This is the increasing order of dipole moment. Why we are writing like that? Increasing order. Here only there is exceptional case between carbon chloride and carbon chloride. The carbon chloride is higher dipole moment than carbon chloride. You should remember this is the order. Here this concept we are studying in nature of CX part. After that we are going to preparation of alkyl halides. Now preparation of alkyl halides. The next concept is methods of preparation of haloalkanes, that is we also call as alkyl halide. Alkyl halides or haloalkanes both are same. We are going to prepare. Now the first method is from alcohols. It is by using alcohol and using phosphorus halide. Either we take phosphorus trihalides or phosphorus pentahalides. Now you know what are the methods to prepare alkyl halides by using alcohols and phosphorus trihalides. To prepare alkyl halides or haloalkanes, alcohols are treated with phosphorus halides to get alkyl halides. To prepare alkyl chloride, alcohols are treated with phosphorus pentachloride. However, to prepare alkyl bromide and alkyl iodide, alcohols are treated with phosphorus tribromide and trichloride. Okay, so observe here by writing chemical reaction, like you know. So here to prepare haloalkanes or alkyl halides, alcohols is treated with phosphorus pentachloride, that is phosphorus halides. Generally take PCl5, or the general reaction take PX5 to get R bond X plus PO X3 plus HC or HX. So this is the general reaction. Here there is 5 halogens and 1 phosphorus, R and 1 halogen plus PO and 3 halogens out of 5. Then 1 hydrogen and 1 halogen becomes HX. This is the general method to prepare alkyl halides by using the alcohol and phosphorus pentahalide. Similarly, phosphorus trihalide, that is alcohols, is treated with the phosphorus trihalide PX3, which is used to take 3 covalents, that is R bond X3, R bond X, that is 3 equivalents, I 3 plus PH3O3, that is PHO3 or PO3, PH3O3. This is the remaining compound, that is H3PO3 or PH3O3. Generally it can be written as H3PO3, phosphoric acid. This is the general method. By using this method we can prepare alkyl chloride, and by using this method we can prepare alkyl bromide and iodide. That only I told in the beginning of to prepare alkyl halides. Now this is the general reaction. Now take example. To prepare alkyl chloride, R bond OH, that is in case of R, take ethane, that is CH3 bond CH2. So this is the ethyl group, tried alcohol, CH3CH2OH. This is called what? Ethyl alcohol. Ethyl alcohol, simply called ethanol, which is reacts with PCl5. Its name is what? Phosphorus pentachloride. Phosphorus pentachloride gives similarly observe, in place of R what we are taking CH3 and CH2. So CH3 and CH2. Then in place of X what we are taking halogen bond Cl plus and P, right same as it is P, there is oxygen O, and in place of X there is chlorine atom, that is Cl3 plus, that is phosphorus oxychloride plus, here there is H and remaining one chlorine get HCl, that is hydrochloric acid. Here the main product is this one, that is ethyl chloride, or we also called as chloroethane. So either you write the common name or impact name, never matter here. So this is the method of preparation of phosphorus ethyl chloride or alkyl chloride. Similarly, to prepare alkyl iodide or alkyl bromide, take phosphorus tribromide or triiodide. Similarly, take the next reaction, that is general reaction. This is general. The particular example, to prepare iodide, that is alkyl iodide and alkyl bromide, take CH3 CH2 bond OH, that is ethyl alcohol, which is treated with PbO3, phosphorus tribromide. It gives, similarly write like that, take 3 equivalents of alcohol from or by using this equation, R in place of R CH3 bond CH2 bond Br, write 3 equivalents plus the remaining compound is H3PO3, that is H3PO3, because already we are using 3 bromine atoms here. So what its name? Ethyl bromide. Similarly, prepare iodide, that is ethyl iodide. Just manipulate the same reaction, just in place of R, write ethyl, that is CH2 bond CH3. What is name? Ethyl alcohol, which is reacts with phosphorus triiodide, that is PI3. So what you get here? 3 equivalents of ethyl iodide CH3 bond CH2 bond iodine plus H3PO3 phosphorus acid. So observe here I write CH3 bond, but here I write H3C. Don't worry, both are same, don't confuse. Either you write like that or like both are right. So this is the way to prepare alkyl halides by using phosphorus halides with alcohols. Similarly, there is next method to prepare alkyl halides by using alcohols and hydrogen halides. The second method is from alcohols using hydrogen halides. Hydrogen halides, under that first one, preparation of hydrogen chloride, alkyl chloride. Preparation of alkyl chloride or chloroalkanes, that is called Gross process. Gross process, important for the purpose of examination. This is the first method, important, that is preparation of alkyl chloride, called Gross process. In this process, alcohols are heated with hydrogen chloride. Alcohol is heated with hydrogen chloride in presence of zinc chloride. You get alkyl chloride, and this whole process is called as Gross process. So that is, alcohols are bond OH. This is alcohol. Alcohol is treated with hydrogen chloride, HCl. Hydrogen chloride in presence of anhydrous zinc chloride, ZnCl2, anhydrous zinc chloride. You get R bond Cl plus this hydrogen, this OH becomes what? Water plus H2O. This is called alkyl chloride. This whole process is called what? Gross process. Here, the mixture of HCl and zinc chloride is called as Lucas reagent. The mixture of, remember, the mixture of HCl and anhydrous, right here, anhydrous zinc chloride is called Lucas reagent. Is called Lucas reagent. Is called Lucas reagent, important for 1 mark. Similarly, take example here, remember, the mixture of hydrogen chloride and zinc chloride is called what? Lucas reagent. So similarly, take example in place of ethanol, that is CH3 bond CH2 bond OH. What is name? Ethyl alcohol or ethanol, which is treated with what? Hydrogen chloride HCl. Hydrogen chloride HCl, which is in presence of anhydrous zinc chloride. And heating, delta is nothing but heating. This symbol indicates the heating. What you get in place of CH3 bond CH2 plus CH3 CH2 in place of OH what? Cl, and the remaining one is H and OH becomes water. So this is the example to prepare alkyl chloride by using using hydrogen halides and alcohols. This process is called as Gross process. Important, if they ask, write example. Don't write general reaction. Write always the example. If they ask particularly, you should write general reaction. Then the third method. So next method, that is preparation of alkyl bromide only by Gross process, that is to prepare alkyl bromide. To prepare alkyl bromide, alcohols is treated with or heated with hydrogen bromide, that is 48% of hydrogen bromide in presence of sulfuric acid H2SO4. Here the reagent is sulfuric acid. In the previous process, we are using zinc chloride and hydrogen chloride. To prepare alkyl bromide, we are using alcohols and 48% of hydrogen bromide, which is on boiling. Not only heating, we have to boil this mixture. Boiling, you get alkyl bromide, that is R bond Br plus H and OH becomes what? Water. So in the last process, to prepare hydrogen chloride, we are just heating, but here we have to go in boiling. It means it increases higher temperature. Our temperature increases. This is the general reaction. Now take example. Example, in place of R, take ethyl alcohol, CH3CH2 bond OH plus HBr, hydrogen bromide, that is 48% of hydrogen bromide in place of sulfuric acid. This is only concentrated sulfuric acid, not diluted, concentrated sulfuric acid, and boiling, what you get, ethyl bromide, that is CH3 CH2 bond Br plus H2. Okay, this is the way to prepare hydrogen bromide. Sorry, alkyl bromide. Similarly, the third method, that is third method, not third method actually, to prepare alkyl chloride, alkyl iodide by using alcohols and hydrogen halides. That is called gross process, preparation of alkyl iodide only by gross process. Alkyl iodide. So similarly, this alcohols R bond OH is on reflexing with hydrogen iodide, which is on reflexing. Reflex. So reflex is nothing but boiling this mixture at very high temperature. The reflex and the boil boil both the liquids becomes vaporizes and becomes condensed in the same flask. That process we call as reflex, which is on reflexing. You get alkyl iodide, that is R bond I plus H2. That is R bond I, and this is becomes water. You get alkyl iodide. Similarly, write example by taking ethanol. That is, example is taking ethanol, CH3 bond CH2 bond OH, ethanol, which is treated with the hydrogen iodide on reflexing. On reflex, what you get? CH3 bond CH2 bond iodine plus H2. So this is the way to prepare alkyl chloride, alkyl bromide and alkyl iodide by using hydrogen halides and alcohols. This whole process is called as gross process. Very important for the purpose of examination. And the third method, by using alcohols only. The third method is by using thionyl chloride, SOCl2, and this process we call what? Darjan process. Darjan process, very important, very important for the purpose of examination. That is, from alcohols using thionyl chloride is called as Darjan process. In this process, alkyl chloride, that is alkyl chloride, is prepared by treating alcohols with thionyl chloride. That is preparation of alkyl chlorides. Alkyl chlorides. So here alcohols R bond OH, it is gender representation of alcohol. This alcohols is treated with thionyl chloride, SOCl2. It gives alkyl chloride. Observe R and Cl. R bond Cl, alkyl chloride plus sulfur and 2 oxygen becomes SO2, sulfur, oxygen and oxygen becomes sulfur dioxide, plus hydrogen and chlorine becomes HCl. This process we call as Darjan process. In this process, we can prepare only hydrogen, only alkyl chloride. We can't prepare alkyl iodide and alkyl bromide. Alkyl iodide and alkyl bromide. This is the demerit of this Darjan process. Demerit of Darjan process. And here we use only thionyl chloride. So example, take in place of RCH3 CH2OH. Ethanol, which is reacts with SOCl2 thionyl chloride and you get CH3, CH2 bond Cl plus SO2 plus HCl. Okay, this is the reaction, and remember this is the method, means best method to prepare alkyl chloride. So already we have studied the two methods, that is by using hydrogen chloride and by using phosphorus halide. This is the third method by using thionyl chloride. Among these three, this dozen process method by using thionyl chloride is the best method to prepare only chloroalkyl, that is alkyl chloride. Okay, this is the method to prepare alkyl halides and haloalkanes from alkones. The next method is by using alkyls, that is from alkenes.